Citizens Forum, and today we have with us Dr. Martin Blank. Among other things, Dr. Martin Blank is the author of the book Overpowered, and it's subtitled What Science Tells Us About the Dangers of Cell Phones and Other Wi-Fi Age Devices, and it's available at better bookstores and online. Now, Dr. Martin Blank has earned two Ph.D.s, one in physical chemistry from Columbia University, and a second Ph.D. in colloid science from University of Cambridge. His research has been on membranes, transport processes, excitation, and recently on health effects of electromagnetic radiation, EMR. In other words, Dr. Blank's work has contributed to establishing the real physical effects on humans from exposure to electromagnetic radiation. And as I said, his book on the effects of EMR is now available. Welcome, Dr. Blank. And I think this topic has been covered, and we see a lot of it in the media all the time. And the public is trying to figure out exactly what are the hazards, and if there are hazards. And in your opinion, is the radiation that's emitted from wireless devices such as the cell phone, is that potentially a harmful agent for human health?
The short answer is yes. The longer answer is the way you expose yourself and the kinds of radiation. There's a whole range of radiation that goes under the name electromagnetic radiation, and some of it is less harmful than others, and some of it we've lived with for a long time, and it hasn't had too bad an effect, although it's like everything else that we have in our technology, that there are good things and bad things. I mean, one would, if you asked, is the automobile dangerous? There are a number of road fatalities every year that will attest to the yes answer. But the fact is we want to live with it. And the same thing goes with electromagnetic radiation. There's a certain amount that people will put up with for the conveniences that it offers.
I think we should always differentiate too between, this is the type of energy that's coming off electrical devices, electronic devices, and it's not the same as the radiation that comes off of nuclear material or radioactive material.
No. This is something that's caused by fields, electric and magnetic fields. The other are basically, alpha particles, which are little bits of nuclei that can do damage. There are electrons, which come off a certain kind of decay. And there are some that are like electromagnetic radiation, the gamma rays that come off from certain kinds of nuclear stuff. So that there is a kind of overlap to some extent.
Yeah.
But this is stuff that, if you take a glass rod and rub it with some silk, you'll build up electrons on the glass rod, and you'll see that it'll attract particles to it.
Yeah.
And this is electrostatic.
Yeah.
And the fact is that this is the kind of stuff that we're talking about. When those electrons are in a wire and they move, they will generate a magnetic field, which will do other things. So it's a complicated world, and I think that's why people take whole courses in physics of electromagnetism, and it gets to be complicated. But the simple thing is that if something has a charge on it, you can affect it with electric fields, with electrodes, or you can affect it with magnets that are. And we use that in our technology. That's how motors work. And that's
exactly. It's very useful.
Yes.
Now, in ionizing radiation, we sort of understand when you get an exposure to some of that type of radiation, it's like an immediate damage to the cells, and it's irreparable, and it could lead to immediate death if the exposure is large enough. But what we find with non-ionizing radiation in general, would it be safe to say that you're not likely to see an exposure cause a very severe health effect in the short term, but you are affecting how the person's the biology is working in the body, and you're setting up conditions that could and had in some cases have shown has led to diseases at a longer range.
Yes, but the thing is, like all these things that are not part of the way the body is normally functioning are disturbances, and some people are more affected by these disturbances than others. So there are people who are very sensitive, for example, the sun, right? The
Yeah.
rays of the sun. And the fact is that that's non-ionizing radiation. Anything less, I was going to say lower frequency, I haven't defined any of that yet, but
Yeah.
it gets to be a very complicated subject, and that's why physicists are trained in it. They take a long time to get trained in it, and the public generally tries to shy away from this kind of knowledge because it's technical and it's complicated. But the fact of the matter is that it affects you because if you take ordinary 60 cycle electricity, that power that we get, that is made up of electromagnetic radiation. Well, no, it's not called radiation at that level because it's not going fast enough. If you think of something going like this, oscillating, that will give you a varying electric field and a varying magnetic field. But the more complicated part about that is that the electric field and the magnetic field don't overlap. One is displaced from the other, so they're sort of going along.
Oh, right.
And the result is that they interact in very complicated ways, and as a result, you get, when the frequency gets to be very close, in other words, they kind of meld, and it becomes a kind of electromagnetic kind of radiation, and that's real radiation because that gets propagated and that has complex effects of its own. Now, I don't want to make this thing sound too complicated because the simple matter is that these fields do affect you.
Yeah.
Because we are made up of the same kinds of particles. We're made up of electrons inside us that are part of ordinary tissue, ordinary matter, and they are affected by these fields, and we respond to it. And so it's very important that we know how these things work and that we try and avoid unnecessary exposure, because the exposures that we get are generally doing things that are going to affect the normal operation and make it go not normally.
Now, would you say that our cells communicate electrically? Is that a fair
Well,
statement?
certainly that's partly true. In other words, they do communicate electrically, but there's a whole lot of communication that occurs by secretion of particular chemicals. For example, nerves will work at a nerve ending. When you stimulate a nerve, you want to move your finger, let's say, point.
Right.
You're getting a nerve impulse that's going down your the nerve,
Yeah.
and at the end it will release I forget. It will release a chemical, something like acetylcholine. Acetylcholine will be transmitted to the other side and interact with something on the muscle end of things and get your finger to move or to point. So that it's a complex thing. The body is very, very, it's got a lot of stuff going on inside it.
Well, I remember reading a book. It's called The Electromagnetic Man, and it was about how the brain functioned, and they were always talking about how there was always an electrical component to how our bodies work. And I remembered that because that to me sort of made sense if there was if the body was immersed in other types of electromagnetic energy, that could easily be disruptive, given that we have a very specific a type of energy that runs our bodies, and these foreign types of energies could influence that. Is that a fair assessment?
Well, I don't know what you mean by foreign. I mean, something like heat, temperature will.
Okay.
Is that foreign? I mean.
Or man-made, say man-made energy.
Light will do things too. For example,
Yeah.
light falls on the retina, and
Yeah.
there's tissue in there that responds to the light. So pretty much everything that in the physical world around us will evoke some kind of response. Even just touching the tissue will get a kind of response inside. So we're a pretty sensitive lot, us human beings, and the fact is we're designed, if you want to think of it that way, to respond to a lot of the stimuli that are around us.
Yeah.
But inside, there's no question that a lot of what goes on has to do with the electrical pulses that come through our nervous system.
Yeah. So, okay, what are, in your mind, are the key scientifically well established biological effects that we should remember when we're considering human health effects of EMR? Like, what science would you point to say, okay, that's quite definitively showing that there's an effect?
That, well, I mean, it's light hitting the retina will give you an effect. Give you a stimulus. I don't know if this is an electrical effect, but I mean, if you push on your mechanoreceptor, there's something inside that will feel the pressure on there. Pretty much everything that goes on in the nervous system is either chemical or electrical.
Maybe I should have phrased it this way. What studies would you point to? Would that be fair to look at, say, this is a study that, shows maybe some, what I say, irrefutable evidence that, that there is definitely an effect on the human body. Do you think there are studies that exist that do that?
Well, I don't know. I mean, you touch an open socket,
Yeah.
You'll get that.
Yeah.
Will tell you. I mean, you'll find out pretty quickly that it's like Mark Twain once said, that something about a cat will know the difference between a hot stove and a cold table. You put one on that stove, it'll jump off.
Yeah.
And I think that's the same sort of thing. I mean, the body has many different kinds of receptors, and they respond to electricity, and they respond to temperature, and they respond to pressure. There are a whole lot of different things. But there's no question that what's happened in our world is that we've become so enamored of electrical devices that they're now proliferating around us to the point where we can't avoid them.
Yeah.
They're everywhere. And as a result, our exposure to these kinds of devices has increased enormously.
Yeah.
And the body was not designed, I mean, I shouldn't say designed, we didn't evolve in a system that would accommodate these kinds of forces. And as a result, they are putting strains on the systems that we have within us. And we're not equipped to live with this kind of level of stimulation.
Now, do you think we've evolved up until the last 100 years or so in the sort of the natural radiations of the universe and of the earth, and it would seem that let's call it creation for lack of a better thing, but all of the life forms seems to resonate with that natural energy. Would that be an assessment, that it isn't something that just we're always having to deal with, but in fact is an important part of our physical lives?
Yeah, I think we kind of evolved in these kinds of environments, and those that were successful in the evolution process were compatible with that kind of life. I mean, those that couldn't adjust to the extremes of temperature, for example, didn't survive there. That's why you've got different populations that live in the Arctic and in the equator areas. So the people differ, and they differ in their tolerance for temperature. And that's probably true also in the amount of radiation that the people will tolerate. They're probably, I don't know if anyone has studied that in particular, but I don't know of any papers on that, but I wouldn't be surprised if that's the case.
Because there'd be very different type of exposure. If you lived on the North Pole, if you lived on the equator, you could see, but the Earth's magnetic field was just so powerful.
That's
nothing
right.
could happen.
And people are worried now about the hole that's existing inside the layers around the Earth that will permit certain kinds of radiation to come through, which hadn't been coming through.
So, like, if I was to look at, and I'm trying to assess whether if this is a real health threat or not, I'm looking on the internet, I'm looking at all the information, I'm looking at references to lots of research and studies. There tends to be two categories of information coming. One is coming from laboratories and from experiments and looking at cells and all that. And then we get a lot of information that comes from human population studies, epidemiological studies. And I wonder, where should I put more weight? Which form of information has got a little more scientific oomph, let's say, than the other? Do you think that the experiments on the cells in the labs give a little more definitive answer?
Well, they'll give you an answer. The other gives you a probability, which is very, very different.
Yeah.
The answer, when you do an experiment in the lab and you find a certain effect to a certain kind of exposure, you can say this is the effect. And then in a lab halfway around the world, if they do the same experiment, they should get more or less the same kind of thing within experimental error.
Yeah.
But the fact is that when you set up an epidemiology study, if you don't get the data right, that is, for example, there was one very bad study in which they were trying to find out the effects of cell phones. And so they said, how do we know who's a user and who's not? Well, we have a registry. Those who registered by a certain date will be users, and those who didn't register are not users. Well, the answer is that some of the people who used the cell phone hadn't registered by that date, and so they were listed as non-users. And the result is that the results were completely useless because they got intermixed. But on the other hand, there are ways in which one can do this kind of study and get useful information. For example, there was a study where you might even say that without any human interference. These are data that were collected on the incidence of cancer around a big antenna system in San Francisco, the Sutra Tower one.
Yeah.
And over 50 years, they collected data of the incidence of cancer in children under 19, and they found that there was a decrease in the number as you went further and further away from the tower. And it was, like you'd expect, just the way it worked.
And you could just draw circles around that tower and you could see.
Basically, the closer you were, the more likely, the greater the probability that there was a large number of cancer studies.
Yeah.
But the fascinating thing about that study was that when you went 2 miles away from the tower and you got the incidence of cancer in children under 19, you found that the level was 1,000 times high. The incidence was 1,000 times higher than what's considered safe. In other words,
The threshold.
Yes, it was above the threshold. In other words, at that level, the stuff, if you had a certain level of exposure, it was considered way below the threshold. And yet the fact is that these are people who are succumbing to cancer, being exposed at levels that are, getting that at levels that are much larger than that.
Yeah, and I mean the discussion around this, and I think you're finding with the idea about what is safe and what isn't safe, and how the government is describing and their definition of safety. Let's say Health Canada's definition of safety, and what in fact happens in the real world. Seems to be two different things.
Yeah, well, the people who set the safety standard are largely non-biologists and non-physicians. There may be a couple on a committee that may have about a dozen to 20 people, but the fact is that they don't use any kind of real biological criterion, because what they say is if this radiation can raise the body temperature to a certain point, that's when there's danger. But if it doesn't raise it at that point, there's no danger. Well, these data were collected. They're just statistics that are assembled by the authorities, and they have it on record. Nobody did a study. They just happen to be filed this way. And they tell you that at that level, the danger is very much larger than you expected.
So you'd have a situation, where I think a lot of these regulations or guidelines that they're using was basically set up to keep the human body from just overheating, basically. Was that the guidelines?
Well, it wasn't so much overheating as that they thought that if it didn't cause any temperature increased by a certain level, then it wasn't dangerous.
Right.
But you know, heat itself is dangerous too.
Yeah.
You get cases of kids that are locked in cars, for example, in the summertime, and they get so hot they actually die from the heat. So heat can be dangerous.
Yeah, at a certain, you know, especially at those high levels. But I think what I'm getting at is that, say, with the Sutra Tower studies and study, people were not, their bodies were not being threatened to be heated up.
No,
But something else was happening to cause illness.
that's no question about that. There's certainly, those are the kinds of data that were not, they weren't studied in the sense that we do an epidemiology study now. They were collected.
Yeah.
They're the kinds of statistics that populations yield just by having people doing different things and suffering from different things. It's and those are the kinds of data that are nice because they tell you, they yield results. A lot of epidemiology studies are set up in such a way as to try and, I shouldn't really say this, but you try and get a result. In other words, you don't want to get certain kinds of results.
Yeah.
And I'm sure people who set up the studies will deny it, but there are a number of studies that show that this is in fact what has been done.
Yeah.
So and they should have known better, which is another way of putting it.
Well, you know, bias. Humans are biased, whether we like it or not.
Yeah,
You know,
yeah.
and we got to find ways of counteracting that, and to so that we don't, you know, we don't have a just presupposed result.
Yeah, but there
We're
are
gonna
ways
find
of
it.
being clever, and there are there are other ways of being so transparently biased that it looks real bad for the case that they're trying to make.
You know, back must be 20 years ago, maybe 25 years ago, there were several power line studies that was this more or less like the Sutra Tower research, where they just looked at who lived near power lines, looked at the load on those power lines, and extrapolated how large the magnetic field would be, or the electric fields, and then came up with a model which was fairly accurate, because they did have historical data on how much power was going through those wires, because it was the power companies kept that. And I think they did come up with statistics that showed that there was an association between how close you lived to those power lines and your likelihood of having certain diseases.
Yes, childhood leukemia.
Leukemia was fundamentally what they were looking at.
Right.
Now, that evidence was fairly powerful, I thought, and there were several studies. And remember the New York State power line?
Yes, they did.
And Dr. David Carpenter, and it was a very interesting political situation there.
Yeah.
And they were seeming time and time again coming up with results which indicated a problem. But nevertheless, it never seemed to equate into changing government policy or regulations.
It did influence the what was it, when they set the standards to say that it was a possible carcinogen.
Right.
That was in 1992, I think, when they set that one, and that was the study that was mainly or that and a group of other studies, but it was on childhood leukemia that they actually used those data to indicate the possibility.
I think the EPA, the Environmental Protection Agency in the United States, did have a report that they were going to make that statement, but I don't think it ever was officialized, or was it?
I think it was.
Okay.
Yes, it was the word was possible carcinogen.
So that's a category.
That's a big stumbling block, because now people are trying to take the same thing with radio frequency, which is what we're at now, which is at the same level, that it's a possible carcinogen, and people are now saying that perhaps it should be changed. Not perhaps, that there is evidence now that one should make it a probable carcinogen.
Right.
And the reason is that there are new data that are indicating that the likelihood is greater. There are more data, and they're more definitive. But of course, they're data. That's one of the problems with epidemiology. You
Yeah.
only deal with things in the probability. It's not like a cell biology study, and that's the stuff that we were doing for many years at Columbia University, and where we could actually find that there were studies that were done. You could establish that there's a threshold at which certain
Yeah.
changes occur, and that these changes are affecting the functioning of the cell. Now, with
Yeah.
one other, if I should just mention that one of the studies that was done very early on, 1992, by Henry Lai and Narendra Singh, which found that if you expose DNA to this radiation, you found that, or to 60 hertz signals, you
Yeah.
found that the DNA actually split little pieces off. You get fragments. And the longer you exposed it, the more fragments you got. Well, that's a pretty strong indication that you're causing damage. But they didn't do that inside the cell. This was the DNA was out. But now they've just done a study where they've done it inside the cells, and they find that there are fragments that result from this kind of exposure, which I think is a very strong indication that the officials ought to move on to the next category, that it's probable, and it
Yeah.
really is a very strong indication that the damage is certainly going to lead to problems, and that could very well result in cancer.
Yeah, I think that was reported in Microwave News,
Yes.
which you can get online, and I can't remember the institute that did the study, the American Toxicology.
I think it's one of the NIH things, I think.
Yeah.
I don't remember it exactly, so I better shouldn't say.
But that's kind of falls into what I was saying. Like, to me, that is the kind of harder evidence, because it's a physical physical response that can be replicated, and you can easily extrapolate that. If that happens in cells, there's a good chance that's going to happen inside our bodies.
Yeah. This happens to DNA.
Yeah.
And when it's exposed. By the way, it happens to lots of chemicals.
Yeah.
You expose it to this kind of radiation, and it breaks apart.
Yeah.
And the thing is that when it breaks apart, it can't function the way it was functioned when it was intact.
That's right.
And
And it can lead to these very serious cancers and leukemia and all that. Now, this is such a big topic, and we're going to have you back if you will come, because I think we always have to kind of get to this point, and there's lots of other more interesting things to talk about in this issue, and it's always so great to have you here. So thanks a lot, Dr. Blank, and I just like to thank all the volunteers and the staff of Shaw for helping make this production possible, and that concludes this segment of Citizens Forum.